GATE Academy online videos. My name is Santosh. In this video, we're going to look at one of the GATE excellent question from the subject of signals and systems from the topic of Fourier series and transfer function. So again, it's an excellent question because we are using three different topics to solve this problem. First of all, I'll start with reading the question. A signal 2 cos 2 pi by 3t minus cos pi t is the input to an LTI system with a transfer function h of s is equal to e power s plus e power minus s. If ck denotes the kth coefficient in the exponential Fourier series of the output signal, then c3 is equal to dash. So let us try to understand this question. The input to an LTI system. We're considering an LTI system whose input is having two sinusoids, 2 cos 2 pi by 3t minus cos pi t. This is the input which is given. So output, let us consider the input as to be x of t and the output is y of t. And the frequency response, the transfer function has been given as e power s plus e power minus s. The transfer function has been given. So we have to find if the Fourier series coefficient of y of t is ck, then what is the value of c3? This is the question. Options given are 0, 1, 2 and 3. Right. So first of all, you have to know how the system is going to respond to a sinusoidal input. So whenever we are giving a sinusoidal input, for example, I give a sinusoidal input as something like a cos omega naught t. Then the response for the system is going to be, m a cos of same omega naught t plus phi. So what is m? M is the magnitude response of the system, which is given by mod of h of omega is equal to omega naught, where phi is going to be angle of h of omega is equal to omega naught. H of omega represents the frequency response of the system. So whenever we give the input as a cos omega naught t, then the output of the system is going to be m into a into cos omega naught t plus phi. What is m? M is the magnitude response and phi is going to be the phase response of the system. So at omega is equal to omega naught, which is the input frequency. So here in this question, we are having two sinusoids. First one at the frequency of 2 pi by 3, the second at a frequency of pi. So what should be the output in that case? The output will be equal to 2 into m1 cos 2 pi by 3t plus phi 1 minus m2 into cos of pi t plus phi 2. Now this particular signal is having the Fourier series coefficient as ck. Now what is the value of c3 is the question. What is the value of c3? So 3 indicates the third harmonic. So we are having directly a trigonometric Fourier series. Okay. Whenever we are writing in terms of cosine functions, we are going to call it as a real Fourier series, which can be either a polar Fourier series or a trigonometric Fourier series. You are given something like cos of omega naught t plus phi, which indicates the polar Fourier series, and we can easily convert the polar Fourier series into a trigonometric Fourier series. So already a real Fourier series has been given to us. Only thing is that we have to know the complex Fourier series coefficient, which is very simple. Once you know the trigonometric Fourier series, ck is given by ak by 2 minus j bk by 2, which is a very important formula in the Fourier series. Okay, so the relation between the complex Fourier series coefficient and the trigonometric Fourier series coefficient. So this is very important, and this is something that we are going to use to solve this particular problem. First thing is that we have to know which frequency is going to represent the third harmonic. So we are having two frequencies here. So whenever we have a group of sinusoids, we have to know the fundamental frequency. The fundamental angular frequency is given by HCF of the frequency which is given, which is 2 pi by 3 comma pi, which is given by pi into HCF of 2 by 3 comma 1. So HCF of any fractions is going to be HCF of numerator, which is 1, divided by the LCM of denominator, which is 3. So the fundamental angular frequency is going to be pi by 3 radian per second. If pi by 3 is going to be the fundamental frequency, 2 times of it is going to be the second harmonic, 3 times of it is going to be the third harmonic. So basically, the frequency which is pi radian per second is going to indicate this frequency component is what we are going to call it as a third harmonic, because we already have a Fourier series. Already we have a Fourier series representation, because we know whenever you are writing in terms of sinusoidal functions, it is going to represent the Fourier series. But CK is the exponential Fourier series, and we have a relation between the trigonometric Fourier series coefficient and the complex Fourier series coefficient, as CK is equal to AK by 2 minus J BK by 2. So this is actually going to indicate what? This is going to indicate the third harmonic of the signal. It's going to indicate the third harmonic of the signal. So we came to know pi is going to be the third harmonic which is present in the signal. Now let us only focus on this particular term. Let us forget completely about this term. Let us consider that that particular term is not there, and we have to just know the C3 value, which always depends upon this particular term. What is M2 here? M2 is going to be equal to the of magnitude of h of omega is equal to the of pi. And phi 2 is going to be equal to phase of h of omega is equal to pi. Right? We already have h of s with us. From h of s, put s is equal to j omega. We can write it as e power j omega plus e power minus j omega, which we are writing it as h of omega. So h of j omega or h of omega, it represents the same. So we can write h of omega is equal to pi is going to be e power j pi plus e power minus j pi, which is equal to minus 2, which we can write the magnitude is going to be equal to 2 and the phase is going to be represented by e power j pi. So mod of h of omega is equal to pi is going to be 2 and phase is going to be equal to the of pi. So this value is 2 and this value is pi. So if you substitute there, you're going to have minus 2 cos of pi t plus pi. Pi t plus pi, which is equal to the of 2 cos pi t. 2 cos pi t. So this is representing the third harmonic, A3, which is equal to 2, and B3, because the sinusoidal function sine term is missing, so we can write the value of B3 is equal to 0. Because whenever we write a sinusoid, we're going to write it as summation of k is equal to 1 to infinity ak cos k omega naught t plus bk sine k omega naught t. So therefore A3 is equal to 2, but B3 is equal to 0 because the sine part is missing. Sine part is missing, so therefore the value of B3 is equal to 0. So the value of C3 is going to be equal to A3 by 2 minus J B3 by 2, which is going to be equal to the of 2 by 2 minus 0, which is equal to 1. So the answer for this question is going to be equal to the of 1. Correct? So what we have done, considering an LTI system, we understood what would be the frequency response for a sinusoidal input. So once you know that, we are using this particular concept, we try to write the input, we try to write the output, then came to know what is the third harmonic of the signal. What is the third harmonic of the signal? So we found out this term is going to represent the third harmonic. So we tried to find out the values of M2 and phi 2 using the frequency response concept. So we got the values of M2 to be 2 and phi 2 going to be equal to the of pi. So we have substituted here and we found out it's only going to have a cosine function. It's not going to have any sine function. So the value of A3 is going to be equal to 2. Every time the coefficient of cos is going to be A. Every time the coefficient of sine is going to be B according to the standard textbooks. So A3 is equal to 2 and B3 is equal to 0. So the complex Fourier series coefficient C3 is going to be A3 by 2 minus J B3 by 2, which came to be equal to the of 1. Okay, it's a very good question. We have to keep solving this particular question if we have to get a very good rank in the GATE examination. So thank you for listening to this video. Keep watching the videos. All the best.